Hello everyone. Today in this video, we are going to discuss about hydrocarbons, which is a topic of class 10th from chapter number 4, that is carbon compounds. Now, first of all, what are hydrocarbons? So hydrocarbons are the compounds which are made up of carbon and hydrogen. These are very important compounds of carbon. We can categorize hydrocarbons into two categories. These two categories are saturated hydrocarbon and unsaturated hydrocarbon. Now, what are saturated hydrocarbon? Saturated hydrocarbon are the carbon compounds, the compound of carbon and hydrogen, which are having only single bond. And unsaturated hydrocarbons are the compounds of carbon and hydrogen, which contains double and triple bond also along with single bond. Now we can categorize these compounds into various categories. Today in this video, we are going to discuss alkanes and cycloalkanes. The various categories of hydrocarbons are alkanes, alkenes, alkynes, cycloalkanes, out of which alkanes and cycloalkanes, these are saturated hydrocarbons. Now, why these are called saturated? Because these contain only single bonds between carbon and hydrogen. Firstly, we'll discuss about alkanes, then we'll discuss about cycloalkanes. So first of all, cycloalkane. So firstly, we'll discuss about alkanes. Now, what are alkanes? Alkanes are the saturated hydrocarbons, or we can say that these are the compounds of hydrogen and carbon with single bond. The general formula of alkane is CnH2n plus 2. This is the general formula of alkanes, where N represents number of carbon atoms. Now, if we take the value of N as 1, so we'll write C1H2, then multiplied by 1 plus 2. By solving it, we'll get CH4. C1H4, we'll not write 1 here. So this compound, this is the first member of alkane, and this compound is known as methane. Okay, so here if we draw the structure of methane, so we can draw the structure of methane like this. The valency of carbon is 4. Now, why the valency of carbon is 4? The atomic number of carbon is 6, and if we write the electronic configuration of carbon, it will be 2, 4. It means it is having 4 electrons in its outermost shell. So its valency will be 4. Now hydrogen, the atomic number of hydrogen is 1. So its valency is 1. So every hydrogen has 1 electron in its outermost shell. So the valency of hydrogen is 1. So here, in this way, we can draw the structural formula of methane. Now, if we have to draw the electron dot structure of methane, how we can draw it? It is carbon, and carbon is having 4 electrons in its outermost shell. So we are going to put 4 dots. Every hydrogen is having 1 electron in its outermost shell. So we are representing it with a cross. So see here. So this hydrogen is having 2 electrons now in outermost shell, and this hydrogen also having this hydrogen also, and carbon, this carbon is having 8 electrons in its outermost shell. So it is the electron dot structure of methane. In this way, we can write the molecular formula of methane, structural formula of methane, and electron dot structure of methane. Now, to get the second member of this we will we'll take the value of n as 2. So when we take the value of n as 2, we'll get to get the second member of alkane in the general formula, that is CnH2n plus 2, we'll put the value of n as 2. Now, if we put the value of n as 2, we'll get C2H2 multiplied by 2 plus 4. So it will be C2H. This 2 multiplied by 2 will be 4 plus 2, 6. So C2H6, the name of this compound will be ethane. For 2 carbon atoms, we use prefix eth, and because it is alkane, so we are going to write it as ethane. Now, ethane is the second compound of alkane series. If we draw its structure, first of all, we are going to take 2 carbons. We are going to join them with a single bond. Now, the valency of carbon is 4. So, we are going to put 3 bonds here. And same with this carbon. Now, 1 hydrogen will be attached at 1 bond. So, this carbon will get 3 hydrogen, and this carbon will also get 3 hydrogen. So, this is the structural formula of ethane. We can write ethane in this way also, or we can show the structure in this condensed form also. If we draw the electron dot structure of ethane, so how can we draw the electron dot structure of ethane? These are the electrons of this carbon which are present in an outermost shell, and these are the electrons of another carbon. They are making a single bond between them. Then this is the hydrogen. This is another hydrogen. This is third hydrogen. So now the next carbon, it is also having 3 hydrogens. So every hydrogen is having now 2 electrons in its outermost shell. In this way, now every carbon is having 8 electrons in their outermost shell. So, and this carbon also having 8 electrons in their outermost shell. So, in this way, we can draw the electron dot structure of ethane. Now, if we put value of n as 3, then we get C3H2 multiplied by 3 plus 2. So it will be C3, 2 multiplied by 3 is 6, C3H8. So it will be propane. The compound which is having 3 carbons, we use prefix prop, and we use ane as it is alkane. Okay. Now, so in this way, we have got the third member of alkane series. Now, if we draw its structural formula, first of all, we have to join these 3 carbons in this way. Now, these terminal carbon will have 3 valencies left for hydrogen. So we are giving it 3 hydrogens. This carbon will also get 3 hydrogen, and this middle carbon will get 2 hydrogen, as its 2 valencies are satisfied with carbon. And we can write it in condensed form also. We can write it in condensed form like this. This terminal carbon will get 3 hydrogen, and this will also 3 hydrogen, and this will get 2 hydrogen. So 3 plus 2, 5 plus 3, 8. So 8 hydrogens are there. So in this way, we can draw the structure of propane. That is the third member of alkane series. Now, if we take the value of n as 4, So what we are going to get, C4H2 multiplied by 4 plus 2, that is C4H10, that is butane. Okay. Now if we draw the structure, first of all we have to make a chain of 4 carbon atoms, and every terminal carbon will get 3 hydrogens like this, and the carbons which are present in between, they will get 2 hydrogens like this. So this is the structural formula of butane. We can write it in condensed form also. If we write it in condensed form like this, terminal carbon will get only 3 hydrogen, and the carbons which are present in between, they will get 2 hydrogen. Now here we can draw it in one more way. Okay, we have joined these 4 carbons in a straight chain, but we can draw this structure like this also. These 3 carbons and 1 carbon as a branch. Now this carbon will get 3 hydrogen, and this carbon will get 3 hydrogen, and this carbon will also get 3 hydrogen. And this carbon, its 3 valencies are satisfied by 3 carbons, so only 1 hydrogen will be given to it. Now how many hydrogens are there? There are total 10 hydrogens, and in this also there are total 10 hydrogens. So you can see that butane can have 2 structures, one in the form of straight chain, another in the form of a branching structure. So these are called as isomers. What are these called? Isomers. So isomers or structural isomers, because their structures, their chemical formula or the molecular formula is same, but their structure is different. So if the molecular formula is same and their structure is different, these are called isomers. So butane is having 2 isomers. This first one is termed as N-butane, and the another one which is having a branch, it is termed as isobutane. Now let's draw the structure of and get the formula of next member of alkane. To get the structure of next member of alkane, we have to put the value of N as 5. So if we put the value of N as 5, the formula will be C5H12. Now here I am drawing it only condensed structure. Add 5 carbons, join 5 carbon like this, terminal will get 3 hydrogen. The carbon which are in between, they will get 2 hydrogen. You can count the number of hydrogens, 3 plus 2, 5 plus 2, 7, 2, 9, 12. So this is one structure. We can draw it in like this also. We can attach 1 carbon here or in between here on this carbon toward this side or here. Now this terminal carbon will get 3 hydrogen, and this also 3, this also 3. Now what about this? 3 valencies are satisfied to only 1 hydrogen, and this one will get 2. Now just to sum up, add the number of hydrogen to 3 plus 1, 4, 2, 6, 3, 9, 12. So same. Now we can draw one more structure like this, 1 carbon here and 1 carbon here. So every terminal carbon will get 3 hydrogen, and this center carbon will not get any hydrogen. So these are the 3 possible structures of pentane. This is known as N-pentane. Okay, it is called as pentane for 5 carbon. The compound which is having 5 carbon atoms, that is termed as pent, and it is alkane, so pentane. So this one is N-pentane, straight chain. This one is isopentane, and this one is neopentane. And these are the isomers, structural isomers of pentane. So similarly, if you take N equals to 6, we'll get the next member of alkane series, that is C6H14, that is hexane. Okay. In the similar way, we can draw its structure. We can draw the isomers of this also. Okay. Next video, we'll discuss about the cycloalkanes.